Hello, welcome to the DMM DYN Servo Drive C# RS232 tutorial. So let's just get started here. We are going to be using Visual Studio. The example that we provided is a Visual Studio sample of C# Windows Forms program. So from the GitHub, what you're going to get is this specific download folder, which includes all the files that are needed for the project itself. So what I'm going to do is start up a fresh copy of Visual Studio. And if I open to a local folder, desktop, open a project or solution. If I click, it's on my desktop. I know it's on my desktop. C# sample program, RS232, this one here, and we can open up this project that is available for download. While we give it a second for this program to load, and it should load up like so. It's basically one form that contains all the functionalities for this demo program, and if we just run this, it should execute. We're running on Visual Studio's 2022 on a Windows 11 computer, by the way. I think it has some .NET dependencies, but it doesn't really matter. The default .NET version of Windows Forms should work for this project. So this program launches like so. The hardware, before we run this, let's just quickly go over the hardware setup. We have a 400 watt motor that's already powered up with a DYN5 servo drive. The RS232 communication, it's the same regardless of which servo drive you're using. So DYN4, DYN5, DYN2, it's all the same. We're just using a DYN5, which is connected to the PC via the JP2 USB cable, and the motor power encoder feedback cable, and the motor power cable, and the AC power to the drive is connected. So the drive is already powered up. By default, from factory set configuration, the drive enables as soon as it is powered up. So you'll notice that when the drive is powered up, the motor shaft position is locked and you can't move it, and you should see a green LED light on the status LED of this drive. So how this program works is, first of all, you need to set the COM port of the drive, and if you press this green button, this help button, it's going to give you some instructions on how to find the COM port. If you don't know your COM port number, go through those instructions, or you can press detect COM port for the program to automatically find the COM port number, the possible COM port number for you. I know that on my computer it is COM4, so I'm going to set that to COM4, and I'm going to press set COM port. And it's going to tell you that COM port setting is successful. If you select the wrong COM port, the program is going to tell you that there is an error setting the COM port. So let's just start this from scratch again, just so I can show you. The right side of this form with all the actual commands is only going to enable as soon as the COM port is successfully set. So you'll notice that in the beginning it's all grayed out, but if I correctly set the COM port, it's going to work. So this is all the commands here: read motor position, read motor speed, read motor torque, read the main gain, and read the drive status. And this is all the functions at the bottom here for certain functions to the drive as to provide the sample code for. So the first thing that we can try is to read the speed, is to send a speed command actually. So if we send a speed command of 10 RPM, and I press the send speed command, you will notice that the motor starts to rotate at 10 RPM in the positive direction, and if I write -50, for example, it's going to rotate 50 RPM in the opposite direction. Keep in mind that all of these data inputs here are not error checked, so if you put in a number like A or something like that, and you send a command of A, it is going to crash out because it only accepts integers within plus or minus, whatever the range may be for that particular setting. So this will probably crash the program if I send a command, so be careful not to do that. But let's just say I send a command of 100 RPM, and I press send speed command. The motor is going to rotate 100 RPM in a positive direction. And if we read the motor speed, we can see the active real-time motor speed that's being read back. And if I read the position, we can see that the position is updating also every time I press this button into this particular text box. And same thing for the torque. Same thing for the gain and the status. If I send a relative position command I'm just going to stop the motor first with a 0 speed command, whatever position this may be. If I send the relative position command of 2000, for example, I've pressed the button. Every time I press the button, the motor is going to move 2000 pulses in the positive direction, and the same thing in the negative direction. So keep in mind that all of these numbers, when you send the command, send the position command, the speed command is always in RPM, but when you send the position command, it's also it does a math to calculate how far it should go depending on the gear number parameter of the drive. So right now I've got it set to full resolution, which means I have a 16-bit encoder here, which means that 2 to the power 16 is 65536, which is the full resolution of the encoder. So any commands, relative or absolute, of 65536 means 1 full revolution of the motor. But this number is scalable. So let's say, for example, if I set the gear number to right now I have this gear number set to 16384, which means internally the math is whatever gear number parameter multiplied by 4 is going to be the command for 1 exact revolution. So when I set to 16384, 16384 multiplied by 4 is equal to 65536. So 65536 is going to be 1 exact revolution. But let's say, for example, if I set the gear number to 500, 500 times 4 equals 2000. So a command of 2000 is going to move the motor 1 exact revolution. But this is only for the position commands. But if you do, this is only for the position command, but for the when you're reading the position back from the motor, it's always going to be at full resolution of the encoder, which is on my 16-bit system, it's going to be 65536. So even if you send a command of 2000 to move the motor 1 revolution, for example, if gear number is set to 500, if you move the motor 2000 pulses to move 1 revolution from the command, it's still going to feed back 65536, which is the full resolution of the encoder itself. So right now it's at whatever position. I can send an absolute position command of 0, and as I keep pressing this, you'll notice that the motor is going back to absolute 0. And if I send to an absolute position command of 60,000, for example, and I press absolute position command, it's going to run to negative 60,000 correctly. So a couple of other functions here to test is to disable the drive. When I press disable drive, the drive disables control of the motor and the motor shaft becomes completely free. And if I press enable drive again, it's going to enable the motor, which means the motor shaft becomes locked and the drive enables control of the motor again. This is a reset function, which resets the drive, which is the same as a power cycle. So if I press which on this single turn system, power cycling and recycling the motor, the drive also causes the encoder position to reset back to 0 because it's a single turn system and it does not remember the position. So right now you can see the motor position is at whatever number, but if I press reset drive, it's going to reset that back to 0. So this is also useful if you want to clear any faults that's within the drive. Right now everything is normal, so if I read the status, it reads back as 0. But if I manually disconnect the encoder cable from the motor, it's going to throw a fault, and if I'm just going to connect it back up so we can boot back up again. As soon as I disconnect the motor, the drive is going to, both the green and the red LED is going to flash, indicating lost phase or lost position error, and the drive is going to stop control of the motor. But if I press, so right now in this error state, if I read the status, it's going to be 7, which it could be 6 or 7. I think 7 means that the motor is off position, so that's why it's indicating a 7. But yeah, so it's going to read a non-zero, indicating that there is a fault inside the drive. But if I press reset and I read the status again, it's going to be 0, and the motor, then the drive is back in control of the motor because it has been correctly reset. So this is all the functionalities within the program. You can go look through all the code to see how everything works. But just for more complete tutorial, I'm going to add a couple of functions into this specific program to show you guys how to do that. So I have the read main gain here, but let's create 2 functions to read and set the speed gain parameter of the drive. So in order to do that, I'm just going to copy a button and a text box for the read first. Let's do the read first actually. So I'm going to copy that. I'm going to name this button, or to label this button as read speed gain, and it's going to read it into this text box 9. So if I double click on this button that we just newly created, it's going to automatically create an action button, an click action function for that particular button press, and I can just copy over whatever is another read function. So for example, I can copy over this one, which read the status, pastes, and I am displaying that into text box 9, I believe. Let me just double check that. Yeah, we're displaying the speed gain into text box 9 here. Text box 9, text equals convert to string class 0.read status, and we're going to create a new function to read speed gain. So which read speed gain function is already written here, which hasn't been called before, but we can call this read speed gain function. So what this, for example, what this is going to do is send a package to the drive saying that function code with function code 19, which means read speed gain, into a drive ID of 127, which means broadcast, and with data 0 because we're reading the package. We're reading something from the drive. We're not sending any commands, and it's going to wait 5 milliseconds. And so this command, when we send this package, it's going to tell the drive to return back to us the speed gain parameter of the drive in the RS232 protocol, and we call this read package function to read the actual bytes inside the serial buffer of the hardware within the computer. So read package calling 11, and it's going to return to us the variable driver speed gain from wherever it's called. So what this is going to do is, and you can look over how it's done inside the code. So when you send the package, read the package, if you read package, it goes through all of here, and then it goes through calculates all the numbers and bytes and stuff like that, and then it's going to run through get function to check the function code of the packets in the buffer. And there is here, which is once it calculates, looks for the function code, it's going to get into the switch case here of hex code function code 11. It's going to see that the function is a speed gain parameter that's inside the serial buffer, and it's calculate the value inside the buffer, and it's going to set the speed gain parameter to whatever that's inside the buffer. So so basically this function is going to return the speed gain parameter of the drive from wherever it's called. So let's just test this, and we're going to display that into text box 9 as a text string. So we can run this program to see if it works. Hopefully it works. Let's give it a second while it's compiling. Set the COM port again to 4, and this is all functional. So read speed gain right now, everything should be normal, and if I press read speed gain, it's going to read the speed gain parameter inside the drive, which is showing 12. So hopefully that's correct. We can test that by creating another function or a button here in the program to set the speed gain. And to set the speed gain, we can copy these two text box and buttons from speed command. So instead of speed command, we are doing set speed gain here, and we are going to take the setting from text box 10. So save that. So from here, we're going to double click on set speed gain function to create that action button, and we are going to copy over the same thing as, actually we don't have a set main gain, but I guess we can copy over from something that we send, so which is the same thing as sending a relative position command. So instead of calling, so when we press this button, we want to call function set speed gain, and then the command is going to be from text box 10, I believe. Let me just double check that. Yes, text box 10. So this set speed gain function is already written, so we can go in here and see how that works. So basically, this is just sending a package of drive with function code hex 11, which is setting the speed gain to broadcast ID 127 and to whatever command that we are giving it, which is the value from text box 10 converted into an integer. So let's run this program. Set the COM port again to COM4, okay, and if we set the speed gain to, don't set it to 0 because that's not going to work, it's not going to be accepted into the drive. If we read the speed gain again, we're going to get 12. If we set the speed gain to 15, for example, and if we read it, it's going to be set to 15. And the main gain is just whatever it is before. So be careful that one thing to note, that all the parameters inside the drive are set are set and read from the EEPROM of the drive, which has a 1 million read-write cycle. So be very careful not to read and write these parameters inside a loop or something like that, because that can destroy the EEPROM, destroy the lifetime of the EEPROM very quickly. But the position, speed, torque, and the status of the drive, here is read and written into the volatile RAM, so that has an infinite read or write cycle. So these position commands and speed commands and the read and the position, speed, torque, and the status can be sent infinitely, but all the parameters settings, read, write, the gain parameters or the torque filter parameters or the gear number parameters, whatever that may be, has a 1 million read or write lifetime in all combined together throughout all the parameters. So reading and writing parameters here from the drive, so is all covered, and you can add whatever functionality you want to the program to read or write to any parameters inside the drive. So one other quick fun thing that we can do to make get more functionality or versatility out of this program is to we can create a timer, a 100 millisecond timer, to automatically read out the position of the motor in real time. So in order to do that, let's create a first we need to create a timer. So if you go into Visual Studio Toolbox, all Windows forms, timer 1, where is it, timers, drag and drop that into the form, we get timer 1. So timer 1, we have to make sure that this is disabled by default, because before the COM port is set, and if we try to read from the drive, it's going to fault out and it's probably going to crash the program. So we have to make sure that timer 1 is only reading. We have to make sure that the timer is only reading from the drive whenever the COM port is already set. So timer 1 by default, make sure it's set to enable, it's set to false. So it's disabled when the form is loaded. And the interval, 100 milliseconds, that's correct. Every 100 milliseconds, it's going to trigger the timer tick value, tick function, which we can write by double clicking on this timer. And it's going to automatically create a tick action function. So every time this timer 1 ticks, it's going to read the position, and what we can do is we can create a text box to show the position. We can put it down here, and if we can toolbox, create a new label to show motor, and then we name this position, put that over here. So text box 11 it's called. So we're going to want to display text box 11 as the motor position. We already have a text box that's displaying the motor position right here, which is button 1, which is read motor position. So we're just going to copy and paste that from there. But instead of text box 1, we're going to write that into text box 11. So every time timer 1 ticks, every 100 milliseconds, text box 11 is going to update the motor position by calling the read pause 32 function, which is right here. And you can go through what this is on your own. So if we go back into this function, or this one, the one thing that you also have to do in addition is to enable this timer whenever the drive is finished setting the COM port, which is actually, if you scroll up a little bit, it's actually this if function here. So I won't go through the details of that or whatever, but whenever the program successfully establishes communication, serial communication with the drive, it's going to go into here. So this is where we need to activate the timer. So this is where you put serial 1 as the text box. So not serial 1 as the text box, but this is where you activate the timer 1. Sorry. So timer 1. What is it called? I think it's called timer 1, right? Timer 1 dot enabled equals to true. So this is where we enable timer 1 as soon as the stereo communication is established. So I think this should be all good to go. As soon as timer 1 is enabled, it's going to start ticking, and every time it ticks, it's going to display text box 11 with the position 32. So let's run this program, and if we right now you can see everything is disabled, it's not reading the motor position. But if we establish communication, as soon as we establish communication with the drive on COM4, it's going to actively read the motor position here every 100 milliseconds. And let's say if I set the speed command to 10 RPM, it's going to update the motor position every 100 milliseconds correctly, and which should match the number that we see here, which is the manual position readout from the function here, from this button. Yeah, meter motor speed 10 RPM. So yeah, you can see motor position updating, and you can use this same concept to put this into some other text box or some chart or whatever to log the or some data logging capabilities of Visual Studio to log the position data. So yeah, you can use all these tools as a base to build some type of controller or HMI or API with an Windows or Linux interface or whatever that may be. Yeah, it's pretty straightforward. And that should cover everything in this tutorial. And of course, if you guys have any questions, or if you want us to add more functionality or show you guys a demo of something else that you want, another functionality inside the drive, feel free to contact us via our email or phone number. Thank you.